Okay, so Newton's second law, what we're going to be looking at today, we want to be able to state the second law and then calculate mass, force, mass, and acceleration by applying Newton's second law. Okay. 1 second. I need to take a slide out of this presentation. I know you can't see my screen right now. Okay, coming back up right now. Okay, all good. All right, so we talked about unbalanced forces last class, and we noted that when forces on an object are unbalanced, we have a resultant force left over. And a resultant force on an object means that it will do what? What happens when we have mismatched forces on an object? Right, we get motion. Good. This question. Can you tell me which force diagram, A, B, C, or D, represents a resultant force of 1 Newton in the direction north? Which one of these force diagrams will have a resultant force or leftover force of 1 Newton pointing up? Snake, what do you say? A, B, C, or D? All right, Mike next. All right, they're going to catch up through the recording. So I'm going to carry on. Antonio, you're correct. It's A, okay? So how did we draw that conclusion? Well, 4 and 2 gives us 6. And then 6 and 6 cancels out. 7 up minus 6 down is going to give us 1. And our motion always goes in the direction of the bigger force. Okay? So that's how we get 1. Okay? So the resultant force causes the object to change its velocity. It accelerates, which means to speed up, or it decelerates, which means to slow down. Okay? The bigger the force, the more it accelerates. The heavier the object, the less it accelerates. Okay? So Newton's law gives us a relationship between three variables: the force, the mass, and the acceleration of an object. If we apply the same force to two different objects, one with a small mass and one with a large mass, the object with the small mass is going to experience the largest acceleration, and the object with a large mass is going to experience a small acceleration. Okay? Mathematically, the relationship between three variables is force is equal to mass times acceleration. Let's try a problem. What force must act on a 50 kilogram mass to give it an acceleration of 0.3 meters per second? All right, so if we pull out our formula, the formula is force is equal to mass times acceleration. We want to find acceleration, so we're going to have to transpose our formula. So if we draw up our little triangle, the force goes at the top, mass, and acceleration. Acceleration is going to be equal to force divided by mass. Plugging in our numbers, so we're substituting now. Oh wait, sorry. Way backtrack. Claire, we're finding force. This is the easy one. We didn't have to do all of that. Force is equal to mass times acceleration. The mass is 50. And the acceleration, we know, is 0.3 meters per second squared. If we plug that in our calculator, multiply that out, we're going to get 15 newtons. Okay? This next one will require us to transpose our formula. So this is just nice and neat. Let's go back. All right. So this one is going to require a little bit more brain power. This is a two-step problem. So it says that the pull of the engine of a jet ski is 3,000 newtons when 1,200 newtons of drag acts against it. That word against tells us that this value is going to be negative, while this one is positive. Okay? And newtons tells us that both of these are forces, so we can combine them. If the jet ski has a mass of 300 kilograms, then what's its acceleration? So in order to find acceleration, we need to know the force and we need to know the mass. Well, we already know the mass, but the force is actually a resultant force because there are two forces acting on this engine. If we turn this into a force diagram, the pull of the engine is the thrust, and that value is 3,000 newtons. And the drag in the opposite direction, and that's 1,200 newtons. So if we were to find the resultant is going to be, well, 3,000 minus 1,200 going to give us 1,800 exactly newtons. Okay? So the total force or the resultant. So all of these words, resultant, total, or if you see the word net, N-E-T, all of those mean the same thing, okay? That you have to combine the force before you put it into your formula. So now we know the force, and we can use our formula to find the acceleration. So the acceleration, if I rearrange my formula, I find the acceleration is force divided by mass. Well, the force is what we just calculated, 1800 newtons, minus the mass, which we're told is 300 kilograms. So when we work that out, we're going to get 1800 divided by 300. We're going to get 6 meters per second.